What if time and space aren't as fixed as we think? Welcome to the world of special relativity.
The speed of light is constant, no matter how fast you're moving.
As you move faster, time begins to slow down. This is called time dilation.
The famous twin paradox: one twin stays on Earth, the other travels in space. Which one ages slower?
Events that happen at the same time for one observer might not be simultaneous for another. Think of space and time as a fabric. Moving objects create distortions, like heavy balls creating dimples.
Energy and mass are interchangeable, as shown in Einstein's famous equation E=mc².
As you approach the speed of light, your mass increases, making it harder to accelerate.
The Lorentz factor shows just how much time dilation, length contraction, and mass increase happen at high speeds. Special relativity reshapes our understanding of the universe, time, space, and reality, forever altered.
As an object moves faster, it appears to contract in the direction of motion.
This effect, called length contraction, occurs only at speeds close to the speed of light. No object can travel faster than the speed of light. It's the ultimate speed limit. Light always moves at the same speed, even when you're moving towards or away from it. Imagine astronauts on a long trip. For them, time moves slower than for those on Earth. Even everyday technology, like GPS, relies on corrections for relativistic effects. Black holes warp space-time so much that not even light can escape. Time also slows down near massive objects, like planets or stars, due to gravity. Light slows down when traveling through materials like glass or water, but never below the speed limit. Einstein's equation E=mc² shows that energy and mass are two sides of the same coin. If you travel close to the speed of light, you'll experience a slower passage of time compared to those who stay still. Although we don't notice it in our daily lives, special relativity has subtle effects even at everyday speeds. Space-time combines 3 spatial dimensions and 1 time dimension into a 4-dimensional fabric. Relativity shows us that there's no absolute frame of reference. It's all about the observer. For moving clocks, the time is stretched, demonstrating the connection between motion and time. When the traveling twin returns, they will be younger than the twin who stayed behind. Time dilation in action. As an object speeds up, its effective mass increases, making it harder to continue accelerating. Though gravity isn't directly part of special relativity, it still influences the fabric of space-time. Einstein's insight revolutionized how we see the universe, not as separate dimensions, but as a connected whole. Special relativity has transformed our understanding of the universe, influencing everything from GPS to astrophysics. In particle accelerators, particles are sped up to near-light speeds, and relativistic effects are crucial to their behavior. Astronomers use the principles of relativity to understand the behavior of stars, black holes, and galaxies. Special relativity paved the way for quantum mechanics and general relativity, reshaping modern physics. The faster you go, the more distorted your perception of time becomes, as shown by relativity. Imagine lightning strikes on a moving train. Special relativity helps explain how the strikes look to different observers. No matter your motion, light always travels at the same speed. This is the cornerstone of special relativity. Events that seem simultaneous to one observer may not be simultaneous for another moving observer. While time travel into the future is possible with relativity, time travel into the past is not allowed. Energy and mass are 2 forms of the same thing. A small amount of mass equals a huge amount of energy. Special relativity has changed how we understand the fabric of space and time, opening doors to new scientific frontiers. What if time and space aren't fixed? Welcome to special relativity. The speed of light is constant, no matter your speed. When you move fast, time slows down. This is time dilation. One twin stays on Earth, the other travels in space. Who ages slower? What seems simultaneous to one observer might not be to another. Space and time form a fabric. Objects bend this fabric as they move. E=mc² shows that mass and energy are interchangeable. As you speed up, your mass increases, making it harder to go faster. The Lorentz factor quantifies time dilation, length contraction, and mass increase.
Nothing can travel faster than the speed of light.
It's the ultimate speed limit. For moving clocks, time stretches, showing the relationship between motion and time. Even at low speeds, relativity affects our lives in subtle ways. Space-time has 3 dimensions of space and 1 of time. Together, they form the fabric of the universe. What you experience depends on your frame of reference. There's no absolute viewpoint. Relativity explains how lightning strikes on a moving train look to different observers. As you approach light speed, time slows down for you relative to those on Earth.
Black holes warp space-time so much that not even light can escape.
Near massive objects, time runs slower due to gravity. Light travels at the same speed, regardless of your motion relative to it.
Relativity allows time travel into the future, but not the past.